The speeches of June on IoT.
I'm very happy that we have the talk from the Uni from Peter Füreder. He speaks in German. Or it is better in English? Yes, definitely. We don't like the first. Kann wer gar nicht Englisch? Yeah, okay, he speaks in English. And the title is The Smart Lab.
Hello, my name is Peter Füreder. I work on the Nestle Research Institute at the VetMed. We are in the cognition, so we have a lot of systems for testing animals. We test wolves, we test hares, we test pigeons, dogs, pigs. We have. Okay. Yeah. We test everything what we find. For example, it was so. I started this 3 years ago, and we didn't have very sophisticated touchscreens or anything. We had normal touchscreens and Windows computers behind it. I show pictures later. It started in 1980s, mid-1980s. We had a Commodore 128, and it had 2 deer projectors and a self-made I/O card. So there was fishes, and the fishes had triggers inside the aquarium, and pictures are shown to the fishes, and they can choose the right one. And then they got food, automated. So they could always, when they had fun, they could play with the machine. The idea of automated learning systems is that you don't have a human interacting with the animals. So this was the first automated machine. All other machines was like there was some person behind a cage or something and feeding or showing pictures and everything. And we found out automated systems are cool because you have always dominant animals. So you have 5 dogs or 5 apes in a cage. Always a dominant gets at first there. And we found out with apes, for example, it was very funny. We had 5 apes in a cage, and there was always on the day, it was always a dominant in there, and in the night there was the least dominant in there, and he played for hours with the machine, and it was one of the best. So it was very cool. And then we tried to improve it with computers. This 128 system was very cool. I didn't see it myself, I only saw pictures. But this must be cool hackers who built it. It was really 2 dia projectors and everything self-made. It was very awesome. The next thing was a backstep. We used Windows XP. The system was proprietary, but already we used $1 wire. It was very cool, actually. $1 wire is not bad. And but yeah, we skipped it, installed Linux, and reprogrammed it. And this was then this one. It was the same hardware, but we used Python. PsychoPy is a library for behavior research. It's very crappy. It's old and programmed by psychologists. You can imagine Python programmed by psychologists. Yeah, so we had then a Node.js core, and we had a Python core and Node.js for showing stuff on the screen, and we connected it with with WebSockets. And this was our first step into WebSockets. It was very cool. There was also another step between. It was an Arduino approach. It was also nice, but it has no computer in the machine. You need a laptop with Windows and run a .NET program, but the feeding machine was already on an Arduino, and this was very nice. It could trigger per funk the feeding machine, and actually I like this program, but it was buggy and we didn't have the source code to rewrite it. So then this is our last iteration actually. Now we totally skipped Python. We went actually to Node.js. We use Sales. And Sales is our middleware, and it is very cool. We use a Raspberry Pi for the moment, but we want to skip it and use a normal EC3C board. There are out very good ones, 400 euros. And we use for the first time GPIOs, and we have a self-built controller card for every trigger or for reading, for Aktual and Sensor. And we want to actually use co-op, the Merkur board, of course. So to make everything modular, so we can have actors and sensors in the whole room everywhere. So we don't have to make cables or stuff like this. This is not good if you have wolves in the room or pigs. They eat up your cables. Yeah. So, and now the last evolution is actually Grunt. I don't know if you know Grunt. Grunt is like Ant in Java. It's a building tool. Bonsai is a SVG library. Power is an installer for the front end, for the JavaScript front ends. Yeah, I will explain this later. This is actually an overview. So this is one of the presentations screens. So normally the animals have left or right to choose. If they choose the right one, they get automatic feeding. And now we can use a tablet, for example, and with WebSockets we are connected, and we can interact if we want, or we can control it, how it runs. The laptop over there should show it's a session running down, and we can use a web front end to make the whole session, to build sessions up for it. It's we had a lot of what is this, native compiled stuff for Windows laptops and stuff. So we decided we go fully web. Everything is web. You can do anything without the Chrome browser. So I go a bit into the stuff. Sales.js is like Ruby on Rails. It's very cool. It's our middleware. It's a connector to the database. It's also the connector. It auto-generates out of your models a few fully API. So it has no front end. It's front end agnostic. And then you write a front end on the REST API. It has everything built in. Express, you know, most of you who know used Node.js know Express. It's a routing engine. And Socket.io is in there and grant the building tools. And our goal is, so we can auto-generate out of the database model, we can auto-generate the GUI. This is our we are working on this now. So, we have our front ends. We have two front ends because we have two users. We have the animals, so that is a touchscreen running in kiosk mode. Kiosk mode is just a full screen mode. And we have our scientists, and they use a session editor. We're using Polymer for this. Polymer, I don't know if you know that, is web components. Anyone of you know web components? It's a new thing, it's very cool. Google builds it in, and Firefox already tries it. It's actually JavaScript and HTML components directly in your browser, and you just call this, and you don't have to program any code if you use like the video tag. If some of you used the new HTML5 video tag, it's web component. And you can write your own web components with Polymer. It's really nice. We have control monitor for our scientists, and we have also the statistics and everything they need for their research. So they can use SPSS to download the research and put it into SPSS. The last point is, very, very, very big buttons. We have scientists, it's really needful. So, what we tried was Dojo, Knockout.js, PsychoPy, many more. One good thing on the university is you have a lot of time to play, and we all skipped it. Dojo is way oversized, Knockout.js is not really good, and PsychoPy is, So GitHub, I don't have internet here. Okay. On GitHub you can find all our stuff. So here are some photos. This is one of the iterations. This is the Arduino-like touchscreen. It's very cool, actually. But it's a feeding machine. Here's a feeding machine. It has here's a funk, the remote for it, and the Arduino controller says yes or right and feeds the dog. This is, and in the back you see the laptop controlling everything. But we want it into one machine, not with all the cables and everything. We want it transportable, so we skipped this version. This is one of the latest ones. It's very cool. It's one big machine. It has here the computer and the dog. You can move the screen up and down and everything. Here is one version of the Wolves. It's a very old version, but it's still working, I think, since 10 years. It's very nice. This is at Wolf Science Center in Ernstbrunn. It's also one of our research centers. Yeah, our new science center is at Heidelhof. We have dogs there, pigs there, and this is our newest touchscreen. It's very cool. It's running on with a Raspberry Pi. It was Evolution 3, and Rudy is one of the best. He likes it. Yeah. It's very cool. This is only a discrimination machine, so you can push left or right. We also have touchscreens where we can put more pictures, so real touchscreens. But it's really expensive because you need infrared touchscreens and put a glass between, because all animals have very wet noses, so it gets very dirty. So with a normal touchscreen, with normal techniques, you fail great. But with infrared it works very good actually. So here's an interior of one of our touchscreens, of the new ones. You see big buttons and they glow. It's cool. And we have a Raspberry, normal. Here's our GPIOs and stuff. And we put in wireless so we don't have to connect any cables. So, this is Benjamin. He's always before his touchscreen hood. He's always standing there, wants to play with the touchscreen. He's cool. We also have here Chaos. This is also an old version. And this is a real touchscreen with infrared. Chaos are very good at it. So, this is my dog. You have any questions?
What's the price of the hardware?
Oh, the hardware is actually very cheap, about 150 euro. Without only the screen, the Raspberry.
And the touchscreen is the most expensive part, I think.
Yeah.
How much is it? The infrared one?
About 800 euro.
Okay.
Yeah. But with the discrimination you saw with pigs, we have glass, Verbundglas, what's in English here. This is the expensive part. We have behind it a cheap 17-inch screen, so it's very cheap. Yeah. It's about €150 with the screen behind. So the glass is more expensive as the hardware, really. It's not so. Yeah.
How long do you keep these setups for? How long do these tests usually run?
The tests itself? Yeah, this depends. The Heidelhof PIC project will run for 3 years. It's a long time, but we have shorters. We have PhDs running multiple projects, so half a year mostly, or it depends.
So in that case, they regularly collect the data but not store it in any central database. They go to the setup and collect the data from the Raspberry directly, and then feed it into their SPSS database or whatever.
Yeah, that's most of the practice. And then they put it into a paper, and never read again.
What is the output from this research? What did you find?
Most of the research is emotions in animals. If dogs, wolves have emotions, also other behavior stuff. Like we have also raben, I don't know what, but ravens. We have ravens, and they look like how ravens group up. The ravens have a group up stuff, like which we have 5 ravens. Sometimes 2 ravens hold together against 3, and then sometimes 4 go against 1, and it's like stuff like that. But behavior, just.
So main focus is on some social impact in the groups of animals or something.
Yeah, it depends always on the animals we test or what we do, which group is testing. We have multiple groups doing science stuff there.
What is the main request on the beginning of all? What is the main request on beginning of this research? Somebody came, okay, we need to research something. What was the question?
No, we have about five or six groups, and every group has another focus. So one group is really emotions, the other is really into finding how the animals interact. And it's different. It's just for every group different. And the leader who is leading them decides what they do. That's about it. Actually, I just built the stuff.
What do you do with all of these animals after tests?
You're talking about the pigs, right?
You're not putting the test.
Unfortunately for you, I must say, no, we keep them alive. For the dogs, in the Clever Dog Lab, we have a Clever Dog Lab at the VetMed University. For the dogs, we don't have any dogs. It's dog owners come to us, and we test with the dog owners, and they go away with the dogs. And we have about 20 students and PhDs and everything, and everyone has a dog. So we have enough dogs to test. It's always good enough. For the pigs, yeah, we have Heidelhof, we have a project running, but it will run at least for 10 years. So, and the wolves, in the Wolf Science Center, of course, live there. The Keas and the ravens, they live also at Heidelhof. They have big voliers and live there. Yeah. We have a lot of animals.
So you do anything with JavaScript and the protocol only is Chrome?
Not only. We also have GPIOs to go with actors and sensors. Yeah. But in the future we want totally go for 6-low pan and coop. So we can use a feeding machine, you know, we can put it somewhere else in another room, be modular. It's also, we have sometimes requests for, can you put the buzzer somewhere in the room without a cable? Yeah. So the dog or wolf goes there and you can push a buzzer, for example, and then in another room something happens. It's also a bit learning for the animals, learning and testing, both the same. And we need it sometimes over multiple rooms.
Do you have any problems with wireless communication?
Problems?
No problems?
No.
Okay.
No, not really.
Because with wireless you always have interference and
No
problem.
You know, these research posts are nowhere and out of nowhere. You don't even have a phone there, so it's not really a problem. Yeah, and then also phones. Yeah.
What database do you use?
Postgres. My colleague wants MongoDB, but Postgres.
Using the database directly, or what's the system there?
This is Sales.js does it. It's a middleware layer between the model and also goes for the database. You can use every database behind Sales.js.
I saw code there on one slide, so are you using code demonstrating application protocol? So you are using as well an slow pump for communication?
Yeah, we use Merkle boards from Michael.
Okay, and was you ever thinking, because I'm still thinking about this emotional research of people and dogs, so you are evaluating the behavior only based on the touch screen. Was you ever thinking about an RFID tag presence which comes to the screen, or maybe monitoring a heart rate or something like that?
We use heart rate measurements. We have polar belts and stuff. It would be fine if we could build our own, because the polar belts really not good, working not good. We also work with we have multiple stuff. But most of the systems are not incorporated. We have eye tracking, for example. We have a machine. It's actually built for humans, but we have it a bit changed for dogs. Yeah, we have eye tracking there. What do we have? Oh. Yeah, we have so many machines. It's really, yeah, actually.
So you are evaluating the data from the more sources to have information.
Yeah, but I'm not evaluating. Our researchers, yeah. They try to get every data they can, and find a clue somewhere.
I was only wondering how it's possible to do emotional research with one touch screen with one picture. So if you have data from the more sources, then it is definitely making sense.
Yeah.
So combinations.
No. They have also stress tests. You know this. Spit. Yeah, with a spit. Yeah, no, this. I forgot how this is called, but they test nearly everything they can get their hands on. You're in a cognition group? Yeah, cognition group. You also testing the animals?
We are not testing animals, but we are testing the systems. There is no difference at all. They are unpredictable as well.
Yeah.
No, that means.
And here you can see the groove board with the shield, and I give it around. And there's a system runs a contiguous operating system, and so you can use Core or MQTT to communicate over IPv6, and they make a mesh net if you have more than one. and on the Raspberry you can put a shield on it, or a Banana Pi, and the Linux system sees the board as a network card, and so you can with routing bring the board to the IP network. On every board have a MAC address, and the MAC address is a part of the IPv6 address. And so you can communicate around the rooms, or the animals, and so on.
It's very cool. OS domotics.
We also have workshops around the board.
Do you use webcams?
We have many cameras. We use mostly consumer cameras, but we also have about 12 axis network cameras. So mostly we use really good network cameras for all recording.
How expensive are they?
About €1,000. It's axis, yeah.
Because I'm looking for cheap solutions with webcams.
The Raspberry cam is not bad. If you use a Raspberry with a camera, there is also what is called. There's an MGPEG software with a Raspberry. It's very good software. You can in the browser you can view the picture, and you can also record it and download it from there. We use this if we have not really we don't really read the video, or only for the surveillance. So only to look at the stuff and see what's going on. We use Raspberry cameras. Raspberry Cam is the software we should use. Yeah. It's easy to install, and at the web browser you can do everything with it. Also time lapse. I used it to record the solar eclipse. It was very cool.
Are the outcomes of your research presented somewhere?
Yeah, of course, in the papers. All our software is open source, and we have it on GitHub. But on GitHub we have right now only snippets we work with. So for the final release, and really working software we will have in about 1 month or so.
Okay, and now if we are trying to identify something what is alive, for example, human or animal, there is a research which is saying that you are able to identify the animal or human based on the way how a live object is moving. Everybody has a specific way of movement. Are you doing also research at this area? That you can identify a live object based on the movement patterns?
I don't know about any research about that right now.
Because that's better to have scan the behavior and then use it for identification than tag every live object, every human animal by a tag. Because you are not changing this, but RFID tag can be forgotten. So.
No, I don't. I'm not aware of them doing this in any way right now.
Why would I distinguish it? I mean, there are only animals in the cage. So only animals should...
So thank you for the talk. We make a break of 15 minutes and then come the next speaker.